We're going to get started just with a brief overview of the spotlight and using it to project textures in Redshift. There's just a few little quirks about it that I found to be pretty helpful to go through. So if we do RS light, this is going to give you the generic Redshift light. We can switch this to a spotlight. And I'm just going to move this up, rotate it so we can actually see stuff. So right now it's just a default spotlight and you get these different parameters. Cone angle is like the field of view. If you go inside of it, this is kind of like you're zooming a camera. It's basically the window size. Fall off angle is like this edge to feather stuff. And for our use, I'm just going to set that to 0 so we get a sharp edge. I basically don't want these other parameters to change or alter the image that we're projecting. And then we can enable a texture. And I'm going to get started with something that's in this HH pick directory. So this is a directory of images that comes with Houdini. You just want to make sure with these, if you're using Redshift, you want to pick a PNG. PIC and RAT are proprietary Houdini image formats, so Redshift might not read them properly. We could just grab this air.png, and now you can see it gets projected. Now I'm going to go to the bottom here and get this uncooked PNG. So we can look at something that's like a grid, just bring up the exposure a little bit. And if we take a look at this texture map, you can just load it using mplay like this. The image that we're projecting is square. And you can see that the spotlight is cropping off the edges. So what I usually do, I would increase the scale here to 2 by 2. So that's repeating it 4 times now in the projection space. But if you disable wrap, then it won't repeat it. So it's just projecting it once, but when we do the scale, you can see the origin is messed up. So it's shifting it like that towards the corner. So just to fix that, you can use negative 0.25 for each parameter, and then you get back to the middle, and this way we're projecting the actual texture map without losing any of the edges or anything like that. So that's if you're doing like a laser effect or you're projecting specific texture maps and you want to have precise control over what you see here and getting the same thing down there. That's just a few steps that I'll typically do to make sure that I'm not sawing off the edges or losing anything or changing the image in any way when I go to project it. The last aspect of this spotlight parameter that's useful is this adjust tab under the texture option. So if we open up the render view here, you can use this to apply a tint to your texture, whatever you're projecting, and that just gives you the ability to art direct the color of everything without having to rebake or reauthor any texture maps. So that's a super useful parameter there. You can try this offset. I don't really find it that helpful, but it just adds the value. So you have a multiplier and then an additive or offset to shift things. So now we have a good understanding of the spotlight projection parameters and how to use it with texture maps. We're going to look at generating our own texture maps inside of Houdini. So that will give us more control and flexibility over the projected look, and we can use geometry and stuff like that to animate and to influence how things will look, and it can change over time. So it'll be a lot less limited than just picking a texture on disk. And I'm gonna make a geometry node. So we'll let us use the SOP network. And I'll just turn off visibility and selectability. And we can just call this laser projection generator. And we'll just go inside. And I'm going to start with a height field node. We're using this basically to give us an image plane in SOPs that we can mess around with and edit. I'm just going to make the size 1 unit by 1 unit, and we'll do the resolution by axis. So right now this is like a 512 by 512 resolution texture map. You can go up to 1024, that's like a 1K resolution. You can keep adjusting it as you need. And the next thing I'm going to do is use the pattern, height field pattern generator. We're just going to use this to make a quick pattern or put some values into the height field. And the way that height fields work inside of Houdini is, even though it's a 2-dimensional volume, the Z, the height, this gets basically the current voxel value gets visualized, projected up by its height or by its value. And let's go into the cells and can reduce the jitter a little bit, reduce the wall. You could add a little bit of blur to soften the edges if you want. And that should be good to get started. And the next thing I'm going to do is just change the way that we're going to visualize this. So if we use primitive properties, we can actually change the visualization to an image type. And when you're doing this, just make sure that you only have one volume, one image plane going into it. So we currently have height and mask, because the height fields usually use a mask to drive, to kind of guide where certain effects are placed. In this case, we don't need the mask, so we can just delete it like that. And now the visualization will show up okay. Otherwise, it tries to lay both of them on top of each other, and you could have a problem. And finally, I'm going to use the height field output node. And we're going to kind of hijack this or use this because it has a copnet inside of it. Right now, I'm not going to use the file name parameter. I'm just going to use this to basically give us a node inside that we can grab or reference in the light to get the texture on the fly. So we don't need alpha. We can set these just to height. We can do RGB. We should be good. The only last thing, if you're not using this, is the save to disk method. Just make sure that you link up the resolution. So I'm going to copy the grid samples axis up there, and you can paste relative references and put this into both fields. And this just makes sure that you get the actual resolution here. And then if I get this flip node, flip 1, I can hit Control C. And when you do that, Control C, copy it, that will give you the node path on the clipboard. So if you go into just this text port here and Control V, you can see this is pasting the full path to the node. So that's a useful way to reference nodes. And I can go ahead and use the op : syntax to reference an operator in our scene instead of a texture map on disk for the light. And if you see this error pop up here, you can hit Control X and then hit Control V just to cut and paste the node back, and that should clear out the error. And now if I go to render again, you can see that it's actually using our cellular pattern, which is pretty cool. You might want to change the brightness or the exposure. And you can change these parameters as well. It doesn't give them to you interactively automatically, but if you hit this refresh, then it will regenerate the texture. You can do something like reduce the wall thickness. You start to get a sharper, more of like a laser look. Another thing you can do is at the end of the chain, sometimes I use this volume mix. This just lets you multiply. It's kind of like a color correction node. So if we multiply the intensity here by 5, then we'll get a stronger, a brighter laser projection. We could also increase the blur. And let's just see what happens with that. I'm trying to get a little bit of almost like aliasing or like dotted lines between the cells, and that can almost give you like a laser, can lend to the laser type of look. You could also put in for the rotation like the current frame, and if this is time dependent, Redshift is smart enough to know to basically grab this texture every frame, so you don't have to keep pushing the recycle or re-render button. You could go with a lower resolution, depending on the pattern, how much accuracy you need. So you get a sense here of how interactive or how quickly you can kind of dial in or adjust the look of your projection, which is pretty cool. And lastly, we still have all these controls up here. If you want to change the color of the laser, you can do this as kind of a multiplier, where it's almost like a gel or a filter on top of your light. And that's the basics of how to quickly and easily generate projection maps for lasers or for any type of spotlight inside of Houdini. All right, so now that we have the basic idea of referencing height fields, the COP2 network, to project textures on the fly that we're generating inside of SOPs, we can move in, go into something a little bit more advanced. So instead of just using this pattern node, it's a bit limiting. I'm gonna make a grid, and we're gonna look at how we can use actual geometry to influence or to bake that into height fields and eventually textures. Let's make this size 1 and 1, and I'm gonna shift this by 0.5 units in X and Z. So we're in the 0 to 1 space. And I'm gonna just go down to 3 by 3 for rows and grids. And then I'm gonna use the ends node. And I'm just gonna use this to unroll the shared points. So that opens up the faces, or just gives us basically the wireframe of the grid. I'm gonna use a VOP network. And if we go inside, I'm gonna do vector to float, and then float to vector. So that gives us access to each of these components, the X, Y, and Z individually. And if we use the bias function for X right here, you can see this shifts everything, kind of squeezes it from left to right. So this is a useful way to replicate kind of like a laser sweeping from one side of the projection or from one side to the other. And we can paste this and do a similar thing for the Z component. And if you wanted to promote these parameters, you could hand animate them and get some interesting, very art directable effects. In this case, I'm just going to drive this with a noise. So we can just use nodes to procedurally animate this instead of making channel keys or expressions or stuff like that. And you can just grab this float to vector and paste it. And that just gives us 3 components to derive this noise from. I'm going to plug time into the first one, and I'm going to plug this up here into this amount. And then I'm going to use this fit range node to remap the output range, or the input and output range. So we want the input range maybe negative 0.2 and positive 0.2. So I think this node tends to output values between negative 0.25 or 0.27 or something like that. But this will give us close to that. So if it goes above or below these input ranges, it will just clamp it right there at 0 or 1. And you could reduce the roughness if you want basically a smoother motion. Increase it if you want more frantic, higher vibrations. And you could also change the first component frequency. This is just how frequent the time will be used to animate this. And you can also adjust the offset if you want a new random outcome. So that's pretty cool. I'm gonna just move this over, copy and paste it, and plug it down there into the other bias for the Z component. And right now these are giving us the same value. The noises are generating the same value because they have the same inputs. So we're always gonna have something that's just diagonal like that. But if you change these components here to just some random numbers, or you could as well change this offset here or any of these offsets, then these will have their own independent, unique motions. You can see they separate and they're both kind of doing their own thing. And I'm going to use the resample node next. And I want to add some more points to these lines. And we want to do this by polygon edge so it doesn't mess up the corners. And then you could do something maybe 0.005. And I'm going to use the rasterize particles. And I'm just going to put this, the particles go into this input, and I'm just going to plug it in right there. And the last thing we want to make sure as well is we use a transform. We can do that right here. So I'm shifting the grid back to the origin. And I'm going to disable the height field pattern. And I'm going to change the particle scale. If you want, you can grab this length parameter here and reference it. And then you have kind of everything synced up a little bit. I'm going to get rid of this multiplier there, and I'm also just going to clamp this down here so it's between the 0 to 1 range for the output values. That way we don't get any super bright out of range pixels or anything like that. And we should be all set. We can give this a try now if we just open that up again. And you can see now we're getting everything updating. It's still pretty quick to update, and that's pretty cool. I'm going to do something quickly here that's just my own personal habit. I like to change this to a relative path and to an expression. like this. And then close the string and the expression. So this gives us a HScript expression that's linking to this. The reason I like to do that is just if you end up renaming things, then this will automatically update. So if you're copying and pasting this into a scene or making multiple lights or projectors with multiple geometry networks, things tend to stay more organized this way using relative references and the expression. If you just have the full string, it might not always update, and it just, to me, it's a personal habit that I kind of have to keep things relative reference. That way, if you put it into subnetworks or HDAs and stuff like that, you shouldn't have any issues. So that's pretty cool. And then I'm just going to go back in here, and we can add some more lines. And that's pretty cool. But one thing, maybe you want this effect, maybe you don't. You can see all of these are getting moved, or pushed, or squeezed uniformly to the edge of the grid. If we want these all to move independently, we can do that pretty easily. I'm just going to use this facet node, and I'm going to set this to unique points. So that's going to give us unique points at all of these areas where it crosses the grid. And I'm also going to switch this to rows and columns. And that way it's not dividing up each face into unique points. It's just taking the entire, each grid line is now its own primitive. So that's pretty useful. And then I'm going to use the enumerate node. So this is going to copy the primitive number into the index attribute. And then we can promote that here from primitive to point. And that way, inside of our VOP network, we'll have a unique attribute that we can use that's an index or curve number. We can reference that just using the bind node, set that to index, and it's an integer. And then if we generate a random number, we can just visualize that quickly with the color. You can see each line is getting its own unique color value here. Instead of assigning that to the color, we could put that into one of these other, actually, I'm just going to add it right here. So we'll add it as like an offset to the time. And you might want to just multiply this. Right now, the results here are just between the 0 to 1 range. So if you multiply it higher, these will get more unique kind of random results. So each line is now sampling, it's getting its own unique time, or its own, the noise is sampling its own unique time position. Without this, everything is getting the same time of the noise function, so you won't get any overlaps. It will just push things all in the same direction. This way they're all getting their own independent noise results, basically. Another thing you might want to do is just make a parameter here. I'm going to call this seed, and I'm going to multiply this by 1,000 and just add that right here. The reason why I'm multiplying it by 1,000 is because it converts it to an integer when we add it. So you want to make sure that you're not missing basically the decimals. So now we can use this up here if you just want a slider to try out different positions of noise. That can be a useful way if you're going through things to quickly try out different random generations or different results. So it just depends what kind of laser, what kind of look you're interested in replicating. But I found that basically having these get their own unique noise times, then you get just a more interesting look overall. I'm just going to switch the angle here to make it a little bit bigger so we don't see the edge there. And we could go back in here and change this maybe up to 800 and reduce that resample length. So you can see we're getting sharper results this way, like smaller lines for the lasers. So just kind of more detail or crispness or sharpness overall. Depending on the resolution and stuff, it will take a little bit longer to generate, but maybe you could change that overall at the very end before you go to render everything. And lastly, if you just want to play around, you can still see that if we enable that pattern and toggle that back on, this is almost like you're compositing images. So if you want to play around with two effects overall, you can layer or start to mix and match different things. And here, you just have to remember that the height, that's like the brightness. So if we increase that height for the pattern, change the time sampling, then you can change the brightness of that, and you can start to get more complex animations or results if you start to mix and match different things like that. I'm just going to turn that off for right now. We can go back and just keep the grid look. I think I like it. It looks a little bit cleaner just with straight lines for now. Another option we have besides generating these textures, sometimes that can be a little bit too much work, or you might want to work more quickly, just grab videos or stuff like that from the internet. So if we take this laser projection and just copy, make a second one like that, I'm going to turn this one off, and maybe looking at just like some videos, you can find stock footage and stuff like that on Vimeo. I happened to download some of these already. Just anything that has kind of a geometric look to it might be useful or might be cool to project that as like a laser type of effect. So if we look at one of these that I already downloaded on disk, it's from the same Vimeo user, and I'm just going to use this terminal with FFmpeg, and you can use the command FFmpeg -I for input, and you can just drag and drop that there. And the output, I'm just going to put this into the temporary directory, and I'm going to use the same file name as like a prefix. And then if you use %04d.bmp, that will be your output image. So this is just taking the video file, the MP4 file, and extracting the frames to BMP like that. And that's basically the quickest way to save images, just without compression or whatever. It's quicker than PNG or other things like that. And then if we use this here inside of Houdini, we just want to make sure that this is, in Houdini you can use $F4, and I'm just going to cut and paste that. So this first light is turned off, and now this one is the only one that's turned on. And now we can see that we're getting that video file projected onto everything. And as well, this works the same way. It has a little bit of color to it by default, but if you want to kind of replace the color, you can just multiply it like that, and you can start to get other cool glitches or unique effects and stuff like that. You just don't have as much control over it if you were to get a note from the art director or creative director or something like that to change the pattern or make it a little bit different in some way. You might not always be able to address the note depending on how big of a change or how much freedom you need in customizing it. But overall, I think both these techniques are pretty useful, either getting videos, generating the texture inside of SOPs. You can as well layer these and mix and match them as well for even more freedom. All right, so we're just gonna add some more lights in here and wrap things up. And I'm gonna disable the video projection for now. One last thing, if you want to change the current frame, like if you wanted to double the speed of this, you can use the expression pad 0 and use 4 for the first argument to add 4 0 padding. It's the same as $F4. If you did $FF times 2, that would give you double the frame rate when you play it back, so it would give you a faster effect. You can as well offset the time if you wanted to shift forward or something like that, which is useful too. I'll just get rid of the air, and I'm going to go ahead and open the render view again. So with these lights that I added, this is just giving us a little bit more of the final look. This is what we had before, and I have some lights coming in now from the side with some expressions. The drift right here is just like a noise, so over time that light might shift up or down. This white background, I've changed the contribution so it doesn't actually light the image. It just gives you like a white kind of backdrop to the image. If you want to adjust things further, I did use a little bit of these post effects. You can play around with those as well. With tone mapping or all of this stuff can be useful as well to dial in the final look of everything. You can boost these values here to be a little bit higher, and then you get a nice bleeding, kind of like overexposure type of effect with this. And I have a subsurface material assigned to this Hulkbuster guy right now. So that gives you a little bit of bleeding or penetrating of the laser into the geometry, which gives you a pretty cool look. So overall, these were different video projection textures that I was trying out just when I was playing around and testing things. And then these are some different shots or camera angles from the setup that you see here. So hopefully you get a nice idea basically of the flexibility or amount of like control and options and stuff like that you have, as well as thinking about using other video sources, or if you're used to After Effects, you can use plugins and stuff like that to generate cool things there. You can even just render out images using Karma or Mantra or anything like that and project those as well.